Hi, this is Faith and Kenny, and this is our phase 3. The topic we chose to focus on was global warming and its relationship with human activity.
For the purpose of this project, we wanted to explore the relations between global warming and human activity, specifically within city limits with the urban heat island effect and emissions productions. Some things that we expected to see were that the temperatures inside of cities would be higher than outside of the city bounds due to the urban heat island effect, and that overall global temperatures have a consistent trend of increasing. Some of the extra questions that we wanted to answer as well were what variables would correlate and possibly cause a more extreme positive heat island effect, and is there a correlation between greenhouse gas emissions and assumed rising global temperatures? For the data collection process, we started off with our CSV. So beginning with fixing the city names, I wanted to use for loops with regex in order to correct that. And I was able to replace instances of question marks within some city names with the correct character completing the name. I also replaced the missing city names and the incorrect values with correct values for certain characters. Along with this, I ended up correcting capitalization errors throughout all the names and generated a list of words that needed to be fixed or altered in order to keep the correct capitalization. And I also input all this data into a data frame and replaced codes with names and dropped some unnecessary data.
For the HTML, I used Beautiful Soup to parse the table. The table was a record of the average temperature anomalies on a global scale over the past century. And these anomalies were calculated by comparing the average regional temperatures to the average of 1991 to 2020 overall. And I use a for loop with a step to loop through the table and get the data. Next. For the API with emissions data, we had some problems with excessive amounts of runtime, so I ended up cross-referencing the CSV country list with the country list available in the API to eliminate any extra processing by casting the list of countries to a set and then back to a list. I also used several try except blocks to catch inconsistencies where there were gaps in the data. To get the actual data, I used nested for loops on a request with a custom URL for each country and emission type. The extra source 1, our only extra source, was used to return a dictionary mapping the ISO 3 country codes to their actual names because all of our data sets only had the 3-letter codes so that we could see what countries we're actually looking at pretty easily. This was another HTML that I used Beautiful Soup on.
For our first insight, we wanted to look at the urban versus urban and buffer comparisons, which is the urban city limits along with some extra kilometers thrown in there so that we could get a good idea of what the temperature looked like outside of the city as well. Our driving question for this insight were what variables increase or decrease the urban heat island effect on cities around the world. And I took the correlation of a bunch of variables that I was able to either pull from a table or generate. And our result is kind of, while none of the variables in the data showed a strong relationship, city size was relatively the strongest and had a positive relationship as was expected. However, there were also some relatively stronger trends in population, which is expected as those two are pretty closely connected and larger cities should absorb and emit more heat on average. For our second insight, we wanted to look at how cities with large populations and small populations compare when it comes to urban heat island effect. And we filtered the cities by a population of at least the 90th percentile, and then we took the top 10 cities with the highest heat island effect in their cities, and we did the same for the bottom 10 percentile and compared these two. And as the visuals display, we found that the heat island effect isn't necessarily proportional to the size, since they didn't really differ much between the two tables, and it seems pretty counterintuitive, and it's pretty interesting to see that the difference between these two population sizes doesn't really make a big difference in the heat island effect.
All right, so here's our first visual, which is related to Insight 3 coming up. I used Plotly Express to create these maps that show the growth rate in the greenhouse gas in moles per meter squared year over year in the troposphere. So as you can see, the function accepts an emission type and returns a map of the growth rate of that emission type. Yeah. So for Insight 3, our driving question when comparing the top 5 methane producing countries and the top 5 fastest growing methane rate countries was, are any of the top 5 first world countries? And the reasoning for this question was that developed countries or first world countries tend to have the highest carbon footprints per capita or per person. And as you can see, pretty much all of these 10 countries are considered developing or underdeveloped countries. And so my thought process on this result was that while the above reasoning is true, developed countries tend to outsource a lot of polluting factory work to undeveloped or developing countries, causing those countries to suffer the actual air pollution consequences of that industry work. Okay, and so here's our data visualization 2. And this visual shows the trend of temperature anomalies over the past century and a half. And so as you can see, all regions of the world, global, southern hemisphere, northern hemisphere, are steadily increasing with high R-squareds and positive rate of growths. And the southern hemisphere, which is shown in the green, is consistently warmer than the north, which led to the driving question for Insight 4. Which is, are there significant differences in temperature by region? And I define significant as at least a quarter of a degree Celsius or more, 0.25. And as you can see in the result, the southern hemisphere is on average 0.11 degrees Celsius warmer than the northern hemisphere, and so there definitely is consistency in this trend, but I found that it isn't too significant. So for insight number 5, I was looking to compare the urban heat island effect and see how closely it was correlated with an emissions output, and since methane was on the rise around the world, I chose methane. And as you can see, there's very low R-squared values compared to the nighttime urban heat island effect and the daytime urban heat island effect. And these two actually have opposite correlations. There's a positive and a negative, which kind of really shows how random and how uncorrelated they really are.
And for our last data visualization, we created a box plot GUI on heat island effect. And this enables us to input the size of cities that we want to observe, the different countries that we want to select for, and the minimum population of the cities that we want aggregated in our data. And it kind of allows us to see that with the visual that is presented here. This is an example of some output that we generated by focusing on some of the countries which have the highest rate of emissions growth. So Bangladesh, first off, was the worst in terms of nitrogen dioxide according to our first visualization. And so we wanted to compare that with the next 3 or 4 countries. The next 3 focus on methane growth, and finally Zambia also represents the highest carbon monoxide growth. And as you can see here, there's a lot of variability within the first 3 countries that we've chosen, which could be due to some of this emissions growth. And also Zambia at the very end has a very large median range compared to some of the other countries within this list. And finally, for our conclusions and results, some things that we saw throughout our data were that the heat island effect does exist. It has little to no correlation with the variables that we define in this project, though, so a good future question would be what other variables we could look at. Along with this, global warming does exist. It's been a trend for over a century, and worldwide methane levels are on the rise while carbon monoxide levels are decreasing. So our future burning questions are, how can we identify other variables and work to mitigate them? Thank you for listening to our project.
Thanks, Dr. McDaniel. Okay, you can cut out the